Perfect.
Okay. Thank you for your help. Appreciate that. Okay, great. So welcome everyone to day 2 of LD4. It is Tuesday. We are at the 10 a.m. lightning talk session. We have 2 facilitators this session. Actually, I'm going to introduce Lozana and the first 2 talks, and then my colleague Uche will take care of introducing Jim and the next presenters. Please be sure to save your questions for the end of the session. Christine is helping us out with chat moderation, and we'll make sure that we catch questions that are happening in the Slack. The chat for this session should be adjusted so that really only co-hosts can talk in it. We want to make sure folks are using the Slack. So just a few reminders on the slide I have up here. The conference website is linked here. We have our code of conduct. If you are using social media to talk about or promote the conference, please use the hashtag LD4_2023. We have Slack invites listed here for the main conference Slack channel, as well as tech support. If you have any issues throughout the conference, please feel free to use it. And a link to our YouTube videos, which will have all of the recorded sessions if they were indeed recorded. So thanks again for being here. I'm going to go ahead and introduce Lozana, who is doing our first 2 lightning talks. The first being Lido to RDF, a linked data transformation pipeline, and modeling artist publication records with the Digital Archive of Artist Publishing. Lozana Rosanova is a digital humanities researcher and designer based in Berlin. She is currently a postdoc researcher at the Open Science Lab in TIB Hanover, working on the NFDI4 Culture Project for a national research infrastructure of cultural heritage data. Rosanova completed her PhD at London South Bank University in 2021, focusing on the redesign of the much beloved ArtBase archive at Rhizome. Her projects typically involve open source software like Wikibase, Compact, and OpenRefine, as well as community-driven approaches to digital infrastructures. Please join me in welcoming Lozana.
Hi, everyone. Sorry that took a minute to unmute myself. So thanks so much for having me. And I have to say, I'm sorry, I will be the sole speaker for the next 2 sessions. Actually, the first one was supposed to be done with my colleague, Paul, but he is in Australia and this time slot was a bit tricky for him. So you'll have to bear with me. I will, the host needs to enable screen sharing so I can share my presentation. Possible? Yeah, perfect. Thank you. And so I'll just go straight into the first presentation. I hope you can see my slides right now. Great. Yes. So I will be talking about our Lido to RDF, Lido or Lido, I never know. I'm European, so I'll go with Lido. Linked data transformation pipeline, which I have to say has really been developed by my colleague Paul Duchesne at the Open Science Lab in TIB. I am presenting it because I am the project manager in the Open Science Lab, and our team lead is Dr. Ina Blumen. So first, the context of this project. The project is happening within the National Consortia NFDI4 Culture, which is a consortium in Germany for research data on material and immaterial cultural heritage, and we essentially build different infrastructural projects for, I'm sorry, I just keep hearing this ping because I think I'm a co-host now, which is, so I keep hearing the ping of people coming in. I'm sorry, it's a bit distracting, but yeah, I'll just continue. So the NFDI4 Culture consortium is consisting of a number of different major cultural institutions in Germany, and we build software and different infrastructural resources for our participants. But also we have partnerships, of course, with people outside Germany too, and we try to make our tools always open source and always reusable. So what I'll be presenting today is, yeah, by the way, if there is a chance that I'm not a host, it actually would be amazing. I think you will need to just give everyone permission to share the screen. I personally feel like that would be better, but I don't know. If the organizers think the participants will not keep pinging in.
No problem. We'll try to turn it off for you. I'm sorry about that.
Yeah, no worries. It's just very hard to
No, I totally understand. I feel
talk if I keep hearing ping, ping, ping. I don't know if I can disable it on my end, actually, the pinging, but I've never done it.
We will try to take care of it between the co-hosts. I haven't either, but we can see what we can do. Sorry about that.
No worries. Thank you. Yeah, so basically we try to build tools that are open source and like easy to reuse by others. And one of our satellite projects that started this year has been working with a number of other institutions to help document Ukrainian cultural heritage in danger. And this particular project where we developed the Lido pipeline has been facilitated in collaboration between TIB, my employer, and Photo Marburg. This is the German Documentation Center for Art History in Marburg. And we've been working also together with Blue Shield Germany, who are a kind of international organization for preserving cultural heritage in danger. So the project was aiming to facilitate endangered culturally significant buildings in selected regions in Ukraine and make them accessible with descriptive data. And the project is essentially consisted of hiring photographers to take photographs of buildings in different stages of, being complete buildings or partially destroyed or completely destroyed. And then that data was going to Marburg, who were processing it and storing the large images into their in-house system and producing Lido data around the images and the buildings. And we, in our on our end in TIP, wanted to create a Wikibase that can manage the metadata around these objects and make it accessible also for community contributions. Now, it's important to say that actually the Wikibase is not open on the web. It is a collaborative system, but it's envisioned to only be accessible, obviously, to kind of people who are stakeholders in this project, and for various security reasons, it's not a completely open project. That being said, we saw a great opportunity with this project to develop a reusable pipeline that will take Lido data, which a lot of cultural institutions have anyway, and transform it into RDF so that it can be pushed into any kind of triple store system. And in our case, it happened to be Wikibase. So what is Lido? I'm sure most of you here are familiar, but I'll just summarize quickly and explain kind of some of the specificity why Lido was used in this particular project. So it's essentially a schema based on CDOC CRM. Lido comes from lightweight information describing objects, and it's based on core elements from the CDOC CRM model, and it's designed for XML serialization. It's quite useful for cultural artifacts, essentially. It's a little bit different from CDOC CRM, which is event-based in the sense that Lido tends to be a bit more object-focused, and there is a hierarchical structure there. I mean, obviously, it's an XML serialization. And this means the physical culture objects are root entities that can then contain child event data, and that child event data can in turn also contain agents. But the model is a little bit more focused on the object, which makes it a friendly format for a lot of cultural institutions and their existing archival systems. Administrative information can be applied to these root entities for like the physical buildings in our case, and then the digital media representations like the photographs would be registered as resources attached to these root entities. It's also worth noting that it's possible to reuse Getty, AAT, Wikidata, or other external entities, which allow for richer object classification. And the first experiments that we tried out in terms of moving Lido closer to an RDF format that we can upload in a triple store was, sorry, is there?
What video? The video?
Sorry, I can't hear. Do you want me to do something?
No, I just had to mute a participant. All good.
Okay, no, I'll just keep going, sorry. It's also a little bit noisy where I am, sorry, it's getting a bit confused. Great, so I'll keep going. So the first experiments that we tried included custom Python script transformations to get from Lido XML to JSON, and that required custom paths to traverse the nested data. We used the pandas JSON normalize function. Yeah, pandas is a library to flatten the incoming JSON encoded Lido data as a tabular data frame. Once the nested data was flattened down into a single table, then actually we could pull columns of data and create the semantic triples that way. Although this approach kind of was a good proof of concept and it proved initial success, we felt it wasn't really the right approach moving forward because it involved a lot of custom code, which would then complicate handover to, for example, other team members or other developers in our consortium. Of course, it was also very, very tailored to the source data. So that also meant like complicating reusability. And we kept encountering a lot of issues with the derivation of persistent identifiers for distinct entities in the source XML. And I'll get to that specific point about the persistent identifiers in a moment. So we opted out to use a different process instead of the custom transformation towards JSON. So we turned towards this project, RML, which stands for RDF Mapping Language. I have to say this is the great thing about being part of a consortium. You can get recommendations from colleagues. And we heard about this project, which actually comes from University of Ghent. And we thought it's really suitable for our use case because it allows to use pre-existing processors such as RML Mapper and RML Streamer. These are two different Java libraries. And we were using them to author reusable transformations via declarative rules. The nice thing is that the transformations are already written directly into semantic triples with standard RDF syntax, which means the future used by other developers who know linked open data would be quite easy compared to our previous custom transformations. And the only requirement here, because the processors are completely already pre-existing, is to create the transformation specification, which also conforms to the normal syntax of Lido, which makes the whole process pretty compact and kind of easy to transport, aka reuse in other projects. It's probably also worth mentioning that the RML Mapper and Streamer libraries, they can work with pretty much any kind of standard input file, and they can output also several different file formats. So all of our work is stored in a Git repo. We used GitLab actually for our NFDI for culture repositories. I'm not going to go into like why GitLab and not GitHub, but it's come up already at the conference I'm in at the moment, DH 2023. So yes, yay for GitLab. I recommend that platform if you're deciding between the two. In any case, you can use our project for to test it, to reuse it. We really encourage other people trying it out because that's the best way for us to kind of get recommendations about what's working, what's not working. Currently, the repo includes the Lido specification with the instructions how to transform the data to RDF, and also instructions how to run the pipeline. And all you need to do to use this pipeline is essentially download an RML preprocessor, and then you have to change in the specification for the transformation, you have to change the source data, obviously, and you can use either local data or remote data, and then you execute the pipeline. And I know I have a minute left, so I'm finishing now. So the challenges, derivation of PIDs across nested entities was a challenge in our process. At the moment, we've been assigning blank, so the pipeline assigns blank nodes to attributes without explicit identifiers. So if there is like a person or any kind of entity in the XML which we think would be reused, we assign a blank node to it, but then we still need to do harmonization to avoid duplication. Another problem that we encounter with this kind of nested data is multilinguality. So in our data set, we had Ukrainian language, German, and English. And the RML transformation process actually requires language to be defined globally or explicitly per entity. And instead, what we had was this inheritance from the nested structure of Lido, and the inheritance was actually not possible to be reused during transformation because we were moving towards a non-hierarchical data triple format. And in theory, we could write some scripts to transfer inheritance from parent to child, but we felt like that would just complicate the pipeline. So we haven't done it yet, but we still don't have a better solution other than telling our data providers to explicitly specify the language for every entity, and or maybe create separate records. And there is yeah, basically a global specification for all the separate languages. And the final point that we found a little bit challenging was, I mean, not necessarily challenging, but you know, it required maybe a bit more creative thinking, is what to do with the Getty, AAT, and Wikidata entities that we inherited in our data set. Single entities were matched to external IDs, but we couldn't really take any benefit from inferencing or searching using taxonomical structure because we only got this, yeah, a single ID and not any of the kind of underlying taxonomy. So we explored alternatives like loading a whole vocabulary in RDF representation into the triple store alongside the generated data, so we can just run queries into our triple store, or alternatively, especially with a source like Wikidata, which is just too big to try to reload completely, we can try using federated queries if we want to do a bit more sophisticated inferencing. And that's it. Essentially, if you have any questions, please get in touch with me. I'll also get in on the Slack, so I'm reachable there, but this is my email. The more technical questions, Paul will be the person to answer them, and I can forward any questions on to Paul, and he can get back in touch with you directly to answer more questions. And now I'm not sure, Kali, should I just go straight into the next presentation?
Sure, that sounds great. Thank you.
Yeah, in the interest of time, I think I'll just do that. Great, so let me just do the presentation view again. Right, and now I'm just gonna switch my hats completely because this project is not from my current employer, the Open Science Lab in TIB, but I presented this project about 2 months ago to the LD4 affinity group for art and design, and I thought actually this might be of broader interest to more people in the LD4 community. So I'm just going to do a very short version of a talk I did in May. And it's about the Digital Archive of Artists Publishing project, and specifically I'm going to focus on how we modeled artist publication records in this project. So this project predates my current work. I started it during my PhD research when I was still in London, and I worked on the project in kind of technical consulting volunteer capacity. Essentially, the project was initiated by this art organization, Banner Repeater. It's an independent artist-led organization in London based on, you probably can't tell from these pictures, but it's based on a train station in central London. It has an archive, a physical archive of artist publishing, and it does a lot of events, exhibitions, etc. It was founded by artist Amy Clark, who really, from the start of the organization more than 10 years ago, wanted to also have a digital presence that could be just as networked and interactive like the space in central London. And so we started talking about establishing a digital archive of artist publishing project, which would be seeded with the Banner Repeater archive, but it would be a more expansive project and very public facing. The idea was that we'll involve artists and make space for artists to create their own records in the archive. So the whole project was done in a very collaborative manner with lots of external consulting from experts ranging from librarians and archivists and publishers of artist publishing through to artists and PhD researchers like myself. And I was primarily interested in working on the technology side of the project because I could apply my linked open data archival skills. And this is just a picture from one of the workshops in 2019 when we were still developing the data model. So I'm going to talk again about linked open data, and I will talk about open source software. My specialty and what we used in this project was the tool Wikibase, which I also briefly mentioned in my previous presentation, but I didn't have too much time to explain. So I'm going to talk about Wikibase in case someone here is not familiar with the tool. So it's a free and open source system for managing linked open data collections. It is essentially the software behind Wikidata, and Wikidata, as I'm sure everyone here knows, is the public knowledge base maintained by Wikimedia Germany. And why is Wikibase so interesting for cultural organizations and different kind of archival use cases? Is because it's possible to run it on your own server and customize it to fit the needs of your own collection. And this is exactly the idea that we had with the DAP. Based on my PhD experience with Rhizome, we thought, well, let's trial Wikibase also for a different, very different kind of material, but still within the art world, art publications. And what are the benefits of Wikibase that I think could possibly benefit any kind of a cultural archive, right? Regardless of if it's born digital art or more traditional art forms. We have a possibility to have multiplicity of voices and not a single canon. Because it's a collaborative wiki system, we can invite the community to contribute to it. What is also really nice is that we have very granular source attribution down to every statement level, which means that it's possible to know exactly where data comes from and to have alternative histories being told about the same cultural objects. And of course, very important, we can also have editing and version control of the data, which all of these things ultimately result in a more transparent approach towards knowledge production and more collaborative. So this is what the DAP looks like. This is a record for a publication in the front-end view. And this is what's happening kind of behind the scenes. We have a Wikibase, which is where everyone in our community can create an account, log in, and add and edit data. And then that data is pulled in real time into a very, very simple, lightweight front-end application. Not all of the data is pulled in. There's a lot more flexibility to add more and different kinds of data into Wikibase, but we have at least a kind of basic view that allows browsing, right? So the main purpose of the web app is to have a kind of very user-friendly browsing experience. We have different indexes in there. They're all pulled, live SPARQL queries pulled from the Wikibase. And of course, we can do nice things with linked open data like these cool visualizations. So how are the possibilities of linked open data applied in the DAP? Essentially, if you've seen any kind of Wikidata or Wikibase record, you will know that at the top of the page, you have the item label, and then next to it, there is this unique identifier like a Q number. In this case, we have here Q3491. Below that, we can have a description, and very nicely, the description can be multilingual, and also the label, of course, too. And below these multilingual simple labels and descriptions, we can have the data statements for every item. The statements consist of three parts. We have the item at the top. This is the first part. Then we have a property, which is essentially a kind of link between different things in the database. And then the third part of the statement is this other thing that can be something else in the database, or a numerical or a textual piece of data. And how are we kind of utilizing all of these possibilities that the Wikibase and software and the linked open data standard allows us is primarily taking advantage of the multiplicity of the data structure. So we can have for every publication, not only multiple people associated with it, but we can also use the qualifiers in the wiki statements to add different levels of qualifying a statement. So in this case, if we have multiple contributors, we can also have multiple roles for these contributors. And the vocabulary that is used to classify roles, for example, is a very flexible and expandable vocabulary. This is one of the kind of foundational principles of our data model in Wikibase, that we can expand it, right? It doesn't have to be a fixed thing. And it's very useful with artist publishing, because artists oftentimes come up with new concepts and ideas all the time. So we want to be able to capture that in the data. I mentioned the source attribution. We tend to use it a little bit more creatively, I would say, than Wikidata. The idea here is not that we want to represent canonical facts that can be pinpointed to a published resource, but rather we want to have the possibility to have conflicting statements. Maybe multiple artists have different memories of how something happened related to a project, so we can add all of those statements and we can attribute where they come from. And this also relates to this concept in the DAP that we want to be able to tell anecdotal histories about the objects in the archive. And this is part of the customization of Wikibase, that we can have long form text sitting alongside our data. Sorry. And we can have metadata describing these long form texts as well. Of course, everything is version controlled, so we can keep track of who is adding what and revert if in case of vandalism or any kind of trouble. Yeah, so with this project, we definitely want to put the community first. It's very important for us that artists and community members have access to add, edit, and improve the data, including the data structure and the vocabulary terms we're using. And the whole project has been really structured around workshops. I just have like a few more slides that I'm gonna quickly run through because I think they are quite foundational to the project. So apologies, I might just need like an extra minute. I just want to say that the kind of fundamental principles behind their data modeling are not completely made up. We have been looking together with our advisors at various existing models, but we also wanted to kind of look at the models and then depart from them where relevant. So we felt that with artist publishing, it's very hard to try to have a hierarchical structure of works and then expressions or manifestations down to items. So we flattened the structure and we only have essentially two layers. We have works and then we have copies, and copies are essentially the same as an item in the Ferber model or the big frame model, but item is used slightly differently in Wikibase as a vocabulary term. So we wanted to use a more simple term and we said copies. Okay, the copy is the physical thing that sits in the shelf in a collection, and then the work is the more abstract entity represented in the DAP platform. And a second edition of a work would just be another work, right? Because artists oftentimes really change the material of publications. They could be printed differently on different paper, etc. So we consider every edition essentially as like a new work, which can be related with different properties to the first edition, for example. The data model consists of different sets of statements for works and copies. For copies, the statements are very minimal. For works, they're much more detailed. So we have things that can describe how the model, how the work is referred to in the world. We have details about the publication event, the material characteristics. Distribution is also important. So different kinds of facsimiles or library links. And then we have anecdotal histories as well. And all of this is available in the slides, which you can download from the shared schedule. The links are there. You can look at the full model. You can also check out a couple of example Sparkle queries that I've prepared, which showcase the potential of the data. And I just want to say that we are not building this only with the binary repeater collection. Like I mentioned, we really want to collaborate with other institutions or even private artist collections. So at the moment we have collaborations with the Women's Art Library at Goldsmiths and with the DEPL in Amsterdam. And that's it. I'm sorry, I'm over time. If you have any questions, I don't know if I have time to quickly take any questions, or if not, I'll be on Slack and you can find me also on email. Thank you.
We were planning to save questions for the very end. Yes, Callie's saying that in chat as well.
I just need screen sharing so I could start my presentation. Okay.
Hi, Uchi, did you want to go ahead and introduce Jim?
I'll go ahead and introduce our next speaker, Jim Han. He's the head of metadata research at the University of Pennsylvania Libraries, leading linked data and metadata projects and research for the libraries. Jim holds an MS and CAS in Library and Information Science from University of Illinois and is a current PhD student in Information Sciences, also at the University of Illinois. He'll be speaking to us on hybrid linked data approaches in traditional discovery environment using shared VDE linked data. So with that, I'll hand over to Jim Han. Thank you so much.
Okay, thanks so much for that introduction. I'm gonna go ahead and just share a link that is the document that we use for our sort of guiding strategy for linked data at the University of Pennsylvania Libraries. We developed this framework in order to help us kind of understand like where we're going and what are the possibilities to get there in terms of both cataloging in linked data and also discovery in linked data. So it talks about some of our principles there. And this is actually from that document where we suggest in terms of defining the hybrid model that it's often possible to include linked data with more traditional representations and make connections between linked data and what we might consider more familiar formats. And it's sort of clear to us that these mixed format environments are probably the way that linked data are used in production in the next few years. But you can read more about that on our, you could download it there. It's just guides.library.upenn.edu/linked-data. And then, so let's talk about something that's familiar, traditional discovery. This is Blacklight 8. I played around with it a little bit this spring, and there is a group of developers in the Penn libraries that are getting ready or have started a project to sort of relaunch our Blacklight using Blacklight 8. And I'll be working in a feature branch, which will help to introduce sort of hybrid linked data discovery. Now, this is data that is just part of like, this is like the vanilla data that comes in the app. And so what I did was search this author, and what you can do is kind of create an association between this author and related works. And so over here, we have sort of traditional MARC data. Over here, this is RDF data that's sort of encoded in the BibFrame vocabulary and is linked data. And so you can see, original works by and publications by this author. So that's kind of the direction we're heading in terms of a hybrid linked data discovery. And then we are using ShareVDE linked data to do that. I should say that it's, I don't expect everyone to know about the ShareVDE project, but it is this collaborative endeavor. And what we're trying to do is sort of create this shared environment in linked data. And there's a couple of deliverables that are available now that ShareVDE produces. So we Penn libraries might send them, a copy of our catalog, and they would enrich that MARC with linked data identifiers. And then also there'd be some clustering, and the clustering, you can express it in the MARC through use of like 758 fields or 800 fields, or even in the 9xx's, but we also get RDF triples. And if you go to svde.org, you can see sort of the discovery in action there. So that's the data that I'm using for some of this. Now, about this feature branch, when I originally proposed this talk, I thought I would have some shareable code for this. I do have some code for Blacklight 8. It's not quite in a shareable place yet, but what I essentially am targeting is this area over here. It's a template override in Blacklight 8, and overrides are really powerful. Here this is like a tool panel that we can add. And basically the way I would approach this is from your Library of Congress name authority, like what's in your 1xx or perhaps in your 7xx. You can map that to the agent in ShareVDE and directly pull that in. So this is like an iframe from ShareVDE that these mappings are something that we create. And then the template override is in Blacklight 8. And this is a feature branch I'll be working on. It would be my expectation that I could hopefully release this as like a plugin at some point, but it's early days in that. And I think towards the end of this calendar year is when we expect to launch the redeveloped Blacklight 8. So that's when we think we'll have this. So I don't have any great code to share with you on this. It was a journey kind of getting up to speed on using overrides and using Ruby code. So not quite ready for sharing yet. I do have some code that I could share about sort of our automated subject assignment experiment that we're doing that makes use of share VDE linked data. And I would just say, like, I was inspired to undertake this experiment by this nice book ops night shift project. And I put links down here, and you can download this PDF to follow along. But basically, there was a copy cataloging bot that uses OCLC numbers. And then there's this sort of nice wrapper to interface with the metadata API from OCLC. And I thought the wrapper was really nicely done. Now, this variation is possibly of use when you can't, you don't have a number, or matching isn't working. So basically, this might be a next step after you've done some matching. Maybe you have some possible subjects, but you want to add more. So this data flow, it begins with brief records, and then we use the titles to a prepackaged machine learning service. The data that are loaded in are the fast subject headings. And then the model is a neural network ensemble. The data are from our Penn Library Share VDE enriched MARC, as well as quite a lot of fast title associations from the Ivy Plus pod data project. So here I'm just getting a row of like ALMA report titles to be published. A lot of the brief records that couldn't be cataloged, we might say that they might be in languages that we don't, they might be in like other languages. So that's one of the, perhaps a blocker for getting these cataloged. And then I use, there's a nice Python client for ONIF. So if you're gonna access it like RESTfully through a web API, here is like a test server that I have at Penn. This won't work for you, but if you go to onif.info, that's pretty much the same service. It's an ensemble of a couple of machine learning projects. And you can see for this title, it has found a score that's above 5, which is kind of what this next part of the project does. It says like, well, if there's any subjects that are over 5, let's go ahead and use that. And then, so from that report, I just have the title. So next thing I'm doing is getting the brief record for that one so that I can add the subject. But before you can add the subject, if you know something about MARC, you need to know like the type of subject we're working with here, because that has implications for your encoding right here. And I would say this isn't pretty, but it's one way to indicate that like the type of subject that you're working with. Once you have that, you can go ahead and add the 650, and you know, this I identified the type of subject that you're dealing with, and then added this 650 here. Then it's ready, more or less ready to be uploaded to Alma. I did test this adding to Alma's sandbox, but it's not quite. We're going to do some scoring with our librarians before we actually before we actually use this as a production service. So there's some scoring, like human scoring, that needs to go into that, which is, we'll do that later this summer. So just some concluding thoughts. Share VDE data, it's quite useful for perhaps non-traditional uses of linked data experimentation and for hybrid linked data discovery. The subject indexing aspects are quite interesting for us because we do have a lot of brief records that we do want to add subjects to. So we think that's a valuable approach. Our knowledge panels for author agents bring in related works and biographical assertions will be also, I think, a fruitful area to experiment with, and it may appear in our Blacklight 8 in the coming year. So if you have any questions, feel free to email me. I just want to acknowledge that this acknowledgement for the data contains information from FAST made available by OCLC and the attribution license for that. So thank you so much. I'll double check chat for any questions.
Thank you so much, Jim. That was a wonderful presentation. So I'll go on to introduce our next speaker. But before that, I would like to give you a reminder. Please save your questions for the end or send them to the Slack channel where they'll be responded to later. So I'll be introducing our next speaker, Kalatoro. Please pardon me if I pronounce your name wrongly. Kalatoro is an astronomer specialized in science communication and open knowledge. Since 2020, she is the community support Media Chile. She will be speaking on benefits of using Wikidata in GLAM institutions. Over to you, Carla. Thank you.
Hi, thank you. I'm gonna share my screen to give a little presentation. And we're here. Okay. Okay, so I'm gonna talk about a little bit about Wikidata and GLAM, the benefits of using this platform. First of all, I'm Carla. I'm the Community Support Officer at Wikimedia Chile. And we work with some GLAM institutions. And for a little bit disclaimer, I'm not working in a GLAM institution, but we work with GLAM institutions. So that's why I want to talk about this. But first of all, I want to talk about what is Wikidata, because if you don't know what is Wikidata, Wikidata is a platform and is hosted by the Wikimedia Foundation. That it's the foundation that it's the foundation that works with all the wiki projects, that host the wiki projects. And Wikipedia, that it's the main project from the Wikimedia Foundation, obviously. But we also have Wikidata, and Wikidata is a database. But the funny thing and the important thing about Wikidata is that all of the information and the structure are in public domain. That means that you can use all the information and you can use the structure that helps Wikidata. Obviously, Wikidata is a linked platform, like a structured database, but also it's a multilingual platform, and that's great because that means that you can edit, you can write, you can read in your language, and that doesn't mean that the content is going to be different from English, from Spanish. It's the same content, but the platform is designed to be multilingual. And another thing that is great about Wikidata is that the information can be viewed in different ways. You don't need to download the data and put it in a, do some Python script or JavaScript to view the information. You can do all of this in the same platform. But what does Wikidata do, and why is it important to, I would say, anyone on the internet? It's because Wikidata can connect other database, and collect a lot of information, and this allows computers and software to see connection between hundreds of data sources. In Wikidata, you can have you can link other database. For example, the Internet Movie Database is connected with Wikidata. The WorldCat entities is connected to Wikidata. So you can think of Wikidata as a database of databases because it's all centralized. And that means that a lot of search engines like Google, right, seek for the information in Wikidata. And it's also because it is machine readable. So if you search in Google, for example, the Mona Lisa, Google will show like a little box with the most important information. And I will say, like, 8 out of 10 times, Wikidata, Google search for that information in Wikidata. That's because it's machine readable and it's easier for the big search engines to go through Wikidata. And if Wikidata doesn't have the information, it has all of the database linked, so it can go to one database to another database. So in this part, well, Mona Lisa is here, and you can have the like a little extract about the information that it's held in Wikipedia, right? But you can have this information that is great because it gives you visibility. And if you look here, it says the location is at the Louvre Museum since 1797. And that information is here in Wikidata. You can see that in the location part, it is the Louvre Museum, and it says start time, the year, and it shows here in Google. So it's all like a little circle, right? So if you ask me, like, okay, how can my institution benefit from Wikidata as a GLAM institution, right? Well, you can have like a lot of things to benefit from this platform. And the first thing is that you can enrich collections, because if you have your collection, your painting, your I don't know, if you are an archive, you have your collections. In Wikidata, you can show or add the context, or you can link the painting to the biography of the artist. Like, you can have this linked information. And obviously, you can increase accessibility because, as I said, Wikidata is a multilingual platform. So if you talk in, I don't know, like a super specific language, you can do that in Wikidata. And myself, that I speak Spanish, I can see the same information in Wikidata. Of course, you can, like, it's a collaborative knowledge sharing. Like, if you don't have all the information, maybe someone can add another information that completes the whole scene, right? And one thing that you can benefit, like, of course, is that you can go and you can be like the authoritative person or institution to the data enrichment and accuracy information on Wikidata, because GLAM institutions have all the information, like the accuracy information, and you can put that on Wikidata. And that's the thing that people will see in, I don't know, like Google or another search engines. Of course, you can preserve and you have archival support in Wikidata, but you want to see like special cases of GLAM institutions that worked with Wikidata and had successful histories, you can go here to this page. Is a page of Wikidata in the Wikidata platform that collects all of these success stories of a lot of GLAM institutions. And another thing that here for to close this little talk, in Wikidata you can visualize data. So if I want to know, like, I'm a big fan of Johannes Vermeer, and I want to know, okay, where are their paintings? In Wikidata, you can control that. You can put that information. And here I search for for a map of the locations of all paintings by Johannes Vermeer that has an image. And it shows, of course, a lot of stuff are in Europe. But if I zoom, I can see that this painting, the guitar player, is especially in London, and I can know where is it, in which museum, and know a lot of the information. So, of course, you can benefit from Wikidata in a lot of ways. And this was like a little short presentation, but I will be happy to answer any questions afterwards. And please don't hesitate to contact me. Here are my contact, and I already uploaded this presentation to the shed. I don't know how to say it, but the platform where all of this is. Thank you.
Thank you very much, Carla. That was a great presentation. So I'll be introducing our next speakers. And our next speakers are Jessica Davis and Ava Kapla. I apologize if I pronounce your name wrongly, really. So Jessica Davis serves as a data research analyst with Pratt Institute Semantic Lab. She is a recent graduate of Pratt Museums and Digital Culture with an advanced certificate in Digital Humanities program. Her interests include connecting people to cultural heritage through linked data, open access, and multisensory knowledge making. While Ava is a data research analyst in the Pratt Institute's Semantic Lab. Ava is also a reference and instruction librarian at Bronx Community College. In addition to linked open data, her interests include digital humanities for cultural heritage and information literacy. They will both be speaking to us on the Semantic Lab Wikibase, one-stop shop for a multi-project knowledge graph. So with that, I'll hand over to Jessica Davis. Thank you.
Hi, thank you so much for that introduction. I appreciate it. So I'm Jessica, and you'll be hearing from my co-presenter, Ava, momentarily. I wanted to welcome you to the Semantic Lab at Pratt Institute's Wikibase, a one-stop shop for multi-project knowledge graph. Co-directed by Christina Paciuelli and Matt Miller, the Semantic Lab at Pratt is a collective of researchers, graduate students, and practitioners exploring new forms and functions of semantic technologies for libraries, archives, and museums. It is an instructional and experimental environment where members can develop and grow their linked data skill sets. Today, we'll share a glimpse into our collaborative approach to model data for projects that represent a wide range of subject areas, many of the titles you can see here on this slide. We leverage just one local knowledge base, Wikibase, to transform, model, and represent this diverse data. The Semantic Lab's interest in the cultural heritage sector is exemplified through the varied projects they produce, such as connections found in the jazz community, elevation of women and other underrepresented communities in jazz, Italian Renaissance studies, musicians' labor unions, the creation of tools that support transformation of source material into linked data. When we created our Wikibase, it provided a hub for some of our existing projects' data to coexist with each other and new projects instead of just being standalone efforts. This has ushered in the potential for cross-pollination and discovery of unrealized interconnectivity through shared entities and triple building. We aren't just accumulating new data, but we're folding in layers of information that enrich and deepen what was previously separate, even revisiting some of those projects in the past. Examples being projects that elevate underrepresented figures and relationships found in the jazz community, such as Women of Jazz and Linked Jazz, respectively. And you can see their presence pre-Wikibase on the left and post-Wikibase on the right. A newer project like EAT plus LOD explore the connections associated with Robert Rauschenberg and Billy Kluver's experiments in art and technology, a genre-defined collective started in the 60s. Additionally, the Asian American Arts Center Exhibition History Project aims to preserve diverse representation and exhibition histories through linked open data. Another key point to highlight here is that there is a variation of the primary sources that we utilize for all these projects. Oral histories, images, videos, brochures, show programs, notebooks, posters, exhibition ephemera, newspaper clippings, concert announcements, just to name a few. As mentioned before, the Semantic Lab currently uses Wikibase, the open source knowledge base builder software, as many of you are familiar with, thanks to our wonderful other programs that kind of came before us, for our knowledge repository. By utilizing Wikibase, it really allows us more control over the data model versus the wild westness of Wikidata, but totally cool. If you're into that, that definitely has its own advantages. But it's interesting to ask, how are others using Wikibase? We found this use includes one overarching topic supported by diverse data sets or record types, and notably enslaved.org. The result of that is really an extensive and focused body of work. Alternatively, the Semantic Lab has been exploring what type of value one Wikibase with multiple projects can yield. Before we get into our findings with the multi-project modeling and one knowledge base, first let's talk about why Wikibase works for us. Really, it's ease of use. Its intuitive interface allows everyone to immediately participate in the linked data experience. And ultimately, our team is largely students, so there is a high turnover, and this really allows for a quicker ramp-up time. We're a part of a community. Benefits of using this open source software is that we have a strong and supportive developer community along with it. We're also a part of a bigger movement, the Wikimediaverse, which accelerates utilization of linked open data. And ultimately, flexibility. It allows us the ability to incorporate new data iteratively, editability without disruption. We're always in a state of modeling flux as we ingest new project data. We can revisit and rethink how we've modeled information in the past. And really, this can prompt us to make Wikibase-wide changes relatively seamlessly. Eva?
Thanks, Jessica. So the Semantic Lab's vocabulary of properties, items, and classes is bottom up, and interoperability is extremely important to us. We map properties to other ontologies such as schema.org, linked art, Wikidata, as well as other linked data projects. We are interested in aligning properties wherever appropriate. However, when the relationships we seek to describe do not align with established schemas, we carefully research and create properties specific to our StemLab projects. The rationale when creating such properties is to always lean towards its potential flexibility across domains, rather than have a proliferation of project-specific properties. In general, when creating new properties, we consider the fact that the Semantic Lab Wikibase is growing, and thus we can expect iterative modeling and consider future property applications, as well as meeting our present needs. Whenever the need for a new property arises, the group comes together to consult other schemas. We discuss the domain range and label, and then we vote to either create the property, find an alternative, or return to it after further research. Next, please. So since all the data from multiple projects and their respective knowledge domains share this one Wikibase and therefore one linked data property vocabulary, the SemLab created some administrative technical properties to link the data to the project it originally comes from. P11, part of project, is an example of such a meta property we use to describe data provenance. This property is also helpful when querying the data, as it serves as a way to filter results according to one or more projects a user would be interested in. Here is an example of a query asking the system to return all data that is both a part of the EAT plus LOD project and the Asian American Arts Center Exhibition History project. And you can see that there are some shared properties and shared items. Some shared properties include sponsored by and location, and some shared items include AT&T, Lucy Lepard, and Namjoon Pike. The part of project property is really helpful for the development of project-specific properties. For instance, P30, mentor of, comes from the linked JAS and its associated sub-projects. It was created for this project and hasn't had much use outside of it. This is because mentorship is an extremely specific and important relationship in the jazz community and is referenced many times by speakers in the oral history primary sources that we used. We needed a custom property to express this very specific relationship. So as mentioned, some properties describe these project-specific relationships. However, many properties are shared across projects, as demonstrated with this graph. Important to note is that many of these properties were originally created to describe one project's data, but as SEMLab's knowledge graph grew and diversified, they were repurposed and applied to new content. For example, P68, performed at, is a flexible property that casts a wide net through domain and range. As you can see, it is part of the linked jazz and EAT plus LOD projects. So just looking at this property in action a little bit, here's the record for Sun Ra, an entity that was derived from the linked jazz project. Here the property performed at links Sun Ra to a performance at Smucker's, a music venue. Next slide, please. So performed at is also used in the EAT project to describe avant-garde performance artworks such as Open Score as seen on this slide, and it connects the artwork to its performance in the event 9 evenings. Next slide, please. So the domain of this property was originally person and music group as demonstrated with Sun Ra's record, and later the artwork was added to incorporate EAT's performance art content as seen with Open Score. Similarly, the range of performed at was at first place, but then expanded to incorporate event when we ingested performance art data with EAT. And so this is just the last slide. Because we're at time, I'm just gonna keep it short, are some reflections and best practices. It's really important we foster collaborative methodology. We're always talking with each other, researching and negotiating across SEMLab projects. Modeling, mapping, and documentation is really central both internally and publicly to guide use. And then we always consider users and domain experts to facilitate primary source research. We frequently speak with the institutions we collaborate with and make sure that our properties are aligning with how researchers as well as the public would intuitively navigate our Wikibase. So thank you so much. Yeah, and we're available for questions.
Thank you so much, Ava. Thank you. Those were really, really great presentations. So everyone, we are really sorry we will not have time for questions. So you can post them to the Slack channel where your questions will be responded to. If you don't have the Slack channel, it was posted to the chat. You can have a look at it. Then you can join through the Slack. You can join the Slack through the link. We have the 2023-conf help channel. If you have any more questions or have any comments, you can ask through the link. So thank you so much for your presentation. Thank you everyone for joining.